What's up, 8th grade? Mr. Pastel here. Today I'm going to guide you through Lesson 1.4, Interpreting Evolutionary Trees. Before we get to the warm-up, I want to show you what the real tree of life looks like. So, in our simulation, the tree is very simplified, but this is the real tree of life. And as you can see, it's got many, many branches, and basically if you start in the middle here, you start out with basically the beginning of life, which was quite a long time ago. And as you go outward, either left or right or up, you get closer to current day. And you can see all of the different kingdoms of life, and not even species. Like every single branch on this tree has many, many, many species. Because there's millions of species that exist nowadays. But you can see the major groups like mammals, birds, reptiles, amphibians, fish, echinoderms, plants, bacteria, fungi, many things. So the point of this is that the tree of life is a lot bigger than what the simulation shows you, but we have to start simple. So let's get to the warm-up. Okay, so we have two species. Look at the body structures and select which body structures these two species share. So which body structures do these species share? I see they both have a tailbones. They both have a backbone. Their skulls are a little bit different. They both have kind of forelimbs, but the forelimbs are just different in size. They don't have the same hind limbs, and they don't have the same skulls. So they have the same tail, they have the same backbone. They both have a skull, but the skulls are different, so let's not select that. They both have a front limb. Different size, though. Okay, do you think this two species from the warm-up have ancestors in common or a common ancestor? Well, all living things have a common ancestor if you go back far enough. So if you ever get a question like, do they have ancestors in common? All things have ancestors in common. It just depends on how far back you go. Even me and you have an ancestor in common. So, some important vocabulary terms here. A descendant species is a species that descended from a ancestor population. So it's kind of like the more recent species. Common ancestor population is the older one, and new species come from one common ancestor species. The descendants come from the common ancestor. So they do want you to look at this graphic in a bit more detail. So humans and blue whales are descendants of a common ancestor mammal. Because humans are mammals, blue whales are mammals. So they had to have a common ancestor in common. In this case, a mammal. So what are the descendants? Humans and whales. What body structures did the common ancestor have? It says right here. It's just reading a graphic. Common ancestor had a backbone, radius and ulna. Those are these two bones right here. Lungs. So whales breathe, humans breathe through lungs. Mammary glands for producing milk. What are the body structures that both descendants share? Everything we just said, because they got them from the common ancestor. But why do paleontologists make diagrams like this? They're trying to show that the descendant species, blue whales and humans, Homo sapiens, got their structures from ancestors, common ancestors. So let's go to the sim. What they want you to do in the sim is pick a body structure. So you have 5 choices. So go to free explore mode. Go to tree. They want you to focus on these body structures, which you'll find in the eye dots. Now, these are not the eye dots we're looking for. We have to expand animals. But that's not one of them either. We have to open all the way up to vertebrates here. So zoom in. This is the first option you have. So you can choose a backbone, and basically everything after this node will have a backbone. So, for example, if I chose backbone, I could say that it says name 2 species that share the body structure. So anything after this node will have the body structure. So hagfishes and sharks have a backbone. You can also choose jaws. So sharks and fishes both have jaws. Or you can say like sharks and crocodiles both have jaws, or ostriches. Everything after this node has a jaw. You have a jaw. It was an important evolutionary trait that evolved. Humerus radius ulna. Let's find that. Oh, here. So everything after this has basically an arm. Ostrich, crocodile, all mammals. Neck, limbs with digits. Oh, so basically all these nodes you can find in the vertebrates page. So you just have to select 2 organisms that have that trait. Okay. I'm going to help you guys a lot with this one. As a thank you for watching my videos. So species inherit body structures. Who do they inherit body structures from? Their ancestors. If 2 living species have some of the same body structures, this means they are probably descendants of a common ancestor population. So they had a recent common ancestor that gave them the body structures that also had these same body structures. Do you think the 2 species from the warm-up have a common ancestor? Yes. As I said, everything has a common ancestor if you go back far enough. The better question is, do they have a recent common ancestor? Or was it a very long time ago? So for the homework, this is harder. This is more tricky. So we have to pick the common ancestor of these 2 species. So let's look at what they have in common. They both have a thick backbone here. They both have a tail. So let's look at that. Which of these fossils has a thick backbone and a tail? Fossil 1 has a thick backbone and a tail. Fossil 4 has a thick backbone and a tail. Fossils 2 and 3 do not. Then maybe you can pick between 1 and 4. Fossil 1, or they both have forelimbs and hind limbs. We definitely have to have a forelimb because both species A and B have a forelimb. Question is, do you like fossil 1 or fossil 4 better? Because A doesn't even have a hind limb. B does. So you can basically just choose one of those. You can actually, yeah, or you can say both, but give some reasoning here. And that's it. Hopefully you learned something today. I'll see you tomorrow.